This week is all about the problem space. And the problem space comes down to understanding what the program is really doing and what it's all about. We're going to look at how to help people understand what this program is, what it does, and how it works. One of the big ways of doing this is the metaphor. And the metaphor is a way of relating this program to something the user already knows. One of the more successful metaphors and most famous is the so-called desktop metaphor. When you look at the top of your PC, you see something that looks like a traditional desktop. It may have a garbage can in the corner, it has documents, it may have pictures of filing cabinets. All of these things are familiar to your average office worker, and they very quickly convey the idea of what these objects do and how to use them. So this is a way of lessening the learning curve dramatically, because now it's, oh, it works just like this thing that you already know, that you already use all the time. So the metaphor is one of the common ways we use to try and instruct people on how to use programs. When people see a new program, they come at it with a certain mental model or a mental understanding of what it is the program does. You take a look at a spreadsheet and you come in and you say, oh, it's like columns and numbers in an accounting sheet which are added up and summed, which is actually not a bad way of looking at it. But it turns out the spreadsheets have a lot of automation, and they've got macros, and they've got all these capabilities that are far beyond what the casual user sees. So the casual user will start out with a very simplistic model, but it's like, oh, it adds up columns, maybe it does some multiplication for you, and it kind of automates what a traditional accounting book might do. But as they use it more, they start to realize there are more capabilities, and this modifies their mental model to encompass the new capabilities that they discover the program has. So your mental model is not fixed. It is something that you start out with, and it evolves over time. One of the big problems is if your mental model is not really accurate. If your mental model does not agree with what the program actually does. And as a result, you will say, oh, if I push this button, something will happen. So you push that button and something different happens. And this is because you've got a wrong mental model and you don't really understand how the program works, because you think it does something slightly different. So what you have to do is you have to correct your mental model. And so this disparity is one of the big sources of errors, where we don't really understand what the program works, or how the program works and what it does. So when a program starts up, it gives you an interface which projects a conceptual model. And that conceptual model is, you look at this interface, you say, I think this interface makes it look like it does this, and it works this way. That is the conceptual model. Now that might be how it actually works, or it might not be. But the better you make the conceptual model, the better it is. From that conceptual model, the user builds their mental model, which is what they understand it does, which might be the same as your conceptual model, or it might be slightly different. Then you have to bring all these things together. You've got to make sure that the conceptual model tries to project what the interface is really going to do and how the program beneath it is going to act. And you have to try and get the people's mental model to correspond to the model that you are trying to project. One of the big problems is when you get a program that is totally different than most people have ever used. I take Photoshop as a good example, because most people don't have a background in image processing, and this is really what Photoshop does. So it's got a huge learning curve because it's all expressed in terms of operations for image processing, which is an area that very few people have any experience with. Yet when you look at other programs for image processing, They may be for photographers, and they go in and they say, photographers use these tools all the time. We'll make their interface in terms of the tools they're currently using in dark rooms or in their cameras or whatever, and we'll make it very familiar with them, or familiar to them. This makes it a lot quicker to learn and a lot more intuitive for the users because it changes it into the user's space of where they're working and thinking, as opposed to an area like image processing where they really don't have any experience and they don't know the terminology or the operations or anything about it. So that's what we're going to be exploring in this topic, all about the problem space.